let me turn on. Okay, so here we go. We are going to talk about probability, sample space, probabilities of compound events, and the counting principle. And we're going to begin with what may be a little bit of review here. So let's look at this spinner. We got Pepe. It's going to spin the following spinner 800 times. So this is an experimental probability problem. The spinner is divided into equal sections. Complete the following statement. So we're talking about the shaded region. So there's 1, 2, 3, 4 out of 5 regions that are shaded. 4 shaded, 5 total. So that means 4 out of 5, right? 4 out of 5 chances it's going to land in the shaded region. So we can multiply that by 800 and we're going to get 640. But does that mean it's going to land exactly 640? No, we can't know that. But we can know that probability-wise, it should be close to 640, but probably not exactly 640. And that is what probability does. It gives us the likelihood of something happening, but not the exact outcome. Just gives us a really good prediction, which is very powerful because nobody can know the future. But if you know the probability, that, is something pretty good. Okay, so I looked at the traffic light problems, and it looks like doing a couple of these problems will help with what was posted. But not a lot was posted yet, so we're just going to go with the most commonly missed questions. We'll do these two. I didn't look at this one yet. You pause the video. Okay, Chase and Emily are buying stools for their patio. They are deciding between 3 heights. 3 heights. Table height, bar height, XL height. 3 colors. And brown, white, and black. And they have created a display to represent the sample space of randomly picking a height and a color. So what you need to know is when you are creating the list of possibilities, you want to do so in an organized fashion. So I could call this T, B, and X. And I could call this BR, W, and BL. So we could get a table height that is brown. We could get a table height that is white. We could get a table height that is black. I put all my table heights in the first, is my list of possibilities. We could get a bar height that is brown, bar height that is white, bar height that is black. And we could get a XL. We could get XL that is brown, and XL that is white, and an XL that is black. So there's 9 possibilities, right? And what's wrong with Chase's table height brown, table height brown? See, he did table height white. Well, that can't be right because he's got 2 of the same thing. So Chase, you lose. All right, let's look at Emily. Bar height, XL height, white, black. Like, what are we doing here? Why are we doing 2 heights and then 2 colors on the vertical side and then a height and a color? Like, that's not good. See, in mine, all my columns are heights, and then my second column is colors. So it's nice and organized. So let's see what she messed up here. So bar height, table height, bar height, brown bar height. So, but what about this doesn't even make sense. Bar height, table height. Table height and bar height. Oh, I don't get it. I don't think that's good at all, but let's see what it says with his. Emily's has fewer than 9 possible outcomes. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So that's a point. But I still don't understand how she's getting the outcomes. I don't even understand. So let's do another one. We're gonna move away from these heights here. Flipping the coins. Okay. So I wanted to show you about flipping coins. I'm glad this is the problem. So you decided to flip 3 coins. Okay. I worked for a whole college semester on these organizing diagrams. So some of the, let me show you my diagram and then we'll look at these diagrams. If I'm going to do the flipping 3 coins, then we have, we can flip like this. We can flip. First of all, there's 3 coins and each has a heads or a tails. So we could get 8 different possibilities, right? And so I know that because of the counting principle, which I'm going to do in just a minute. So the way that I set it up, so it's nice and organized and includes all the possibilities, is I start out with 4 H's and 4 T's. And then I alternate every 2. And then I alternate every time. Told you this took me a long time to figure out. So now we get all our possibilities. 3 heads, 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 and tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Isn't that good? So do the 4, the 4, the 2, 2, 2, 2, and then the every other. If you just had 2 coins, then you could just do the, well, if you just had 2 coins, then it'd just be 4 possibilities, right? So it's going to be heads, heads, tails, tails, and then heads, tails, heads, tails. Kind of use the same sort of thing. So let's look at what they did. I like this one so far. Heads or tails. If it's heads, it could then be heads or tails. And then if it's heads, it could be heads or tails. Heads and tails, it could be heads or tails. And then if it's tails, after that, the next could be heads or tails. And then after that, the third coin could be heads or tails. And if it's tails, so then you get 1, 2, 3, 4, 5, 6, 7, 8. So the thing to remember is that you're going to have 8 possibilities at the end, and all of them are represented. So diagram A looks like a winner. Let's see if I'm right. I'm off. Diagram A. There we go. Any questions? Write it down as a traffic light. Let's move on. Okay, so I'll give you a second to write this down. Here you go. Probabilities of compound events. You're playing a game where you defend your village. No, let me do this one after. Okay, there are 3 characters, an elf, a hobbit, or a human, and 5 defense tools: magic, sword, shield, slingshot, or umbrella. If you randomly choose your character and tool, what is the probability that you'll be a magic elf? So here what we're going to do is we're going to set up our sample space, and then we're going to count how many of those possibilities would make you a magic elf. Okay? Can I undo? Where's my undo button? Like here in my coin toss from the previous question, you could say, what is the probability that you get 3 heads in the 3 coin tosses? And we can see that would be 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So there's a 1/8 chance of 3 heads in 3 tosses. Or maybe use my undo button. Maybe we want to know how many times are you going to get two heads if you toss a coin 3 times? So then we could count. Well, there's 1, 2, 3. It looks like 3. So 3 out of 8. 3 out of an eighth chance of 2 heads in a toss. In 3 tosses. I am so sorry. So that is just to say that we're going to do the same thing with this. Okay, so we're going to set up our sample space. 3 characters. Elf, Hobbit, Human. And 5 defense magic tools. So we're going to have 15 possibilities. Okay, so how am I going to do it? I know I'm going to do 15. So I'm going to do elf, 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 hobbit, 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 ho, ho, ho. Human, human, human. And then a magic sword or shield, slingshot, umbrella. So it just looks like am I, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I definitely got to put 2 more elves here. And then I got to put 2 more. See, I got to put 2 more hobbits. And I got to put 2 more, right? Because I got my 5. So I got magic. I got sword. I got shield. Slingshot. Magic sword, shield, magic sword, shield, slingshot, umbrella. And so you can see we're going to go right down the list. Magic, sword, shield, slingshot, umbrella. Magic, sword, shield, slingshot, umbrella. So there's only one magic elf out of 15 possibilities. So I'm going to say 1 out of 15 chance. And look at that. 1 out of 15. So they set it up like that. I like my lists. What can I say? It helped me, I guess. But you can set up a table too. We could put it down the side like that and down the side. I like that better. That might be a better idea. So then if we're gonna do that, we're just gonna make gonna put one of the categories is gonna be the width, one is gonna be the length, and then we're just gonna fill it in. So if I put elf, hobbit, human up there, and then magic, sword, I keep saying sword, shield, slingshot, umbrella, then this is gonna be a magic elf. This is gonna be a human magic, a hobbit with magic, sorry. This will be a human, and this is gonna be an elf with a sword, and so on. We're just gonna kind of go all the way over and up and see where they meet, like a battleship. Okay, let's use that strategy for the next one. See how it goes. Oh, this is okay. This is great. So this is exactly what I would use. I am not. Look at the answer there. I didn't see it. Okay. I actually already use the table strategy when I do dice, so it works out. Okay. If you roll 2 fair-sided 6 dice, what's the probability that the sum is 5 or lower? So we are going to put 1 die across the top. These are the possibilities of rolling a die. You can get 1, 2, 3, 4, 5, 6. I'm also going to put them along the other dimension of what will become a rectangle. Ooh. I'm just making spaces here. So in between the numbers, and then there in between the numbers, and you can do the same thing. Perhaps yours will look nicer. But okay. Need to judge there. All right. So one possibility of rolling two die is getting two ones, a one and a one, which I'm going to put the sums on the inside. So that would be two. A one plus two is three. 4, 4 is 5, 5 is 6, 6 and 1 is 7. Okay, so what are we doing on the inside here? We are adding the numbers together. So actually, add these pretty fast. And then 2 plus 2 is 4. Nice thing about this is the numbers go in order. So you can just kind of fill them in. 5 is going to be 6, 7, 8, 9, 10, 6, 7, 8, 9, and 11, and 7, 8, 9, 10, 11, and 2 6s would be 12. So now that we've filled in all our sums, we can just count how many of them are 5 or lower. So we have our little wall of 5s here. 1, 2, 3, 4. But then we also have 5, 6, 7, 8, 9, 10, a total of 10 sums that are less than 5. How many sums do we have total? Based on the counting principle, there are 6 possibilities or 36. I don't have to count all these. I know that 36 total. So 10 out of 36. We can reduce that number to 5 out of 18. Hey, and that's what they did. Okay, we're in good shape. You got your compound event. Again, make the rectangle. And the last one, I don't know why this is the last one, because it seems like the easiest one, the counting principle. So we're just going to see how many possibilities each event has, each category has. And then we're going to multiply those together, and that is the total number of combinations. So let's do that. Edwin needs to buy a car, truck, or motorcycle. So that's 3 for a shipping business. He wants the car to be red or yellow. Oh, okay. Car can be red or yellow. So that's 2, right? He wants the truck to be black, white, or silver. The truck could be 3 different colors. And he wants the motorcycle to be green, blue, or orange, another 3. How many different combinations of vehicles does he have to choose from? So there's 2 types of cars, 3 types of trucks, and 3 types of motorcycles. We multiply those together. 6 times 3 is 18. Let's see if I'm right. 18, there you go. The total number of color combinations can be found by multiplying each type of vehicle 2 times. Let's do one more. That was so fun. Bruno is designing his next skateboard. The skateboard store has 3 types of grip tape, 13 types of decks, and 7 types of trucks. We get a skateboard. What's a truck? 4 types of bearings, 2 types of wheels. Wow. So we're going to multiply all those together. Right? How many different skateboards can you create? assuming all those things have to do with skateboards. Somebody that's a skater will have to let me know. So I'm just going to take and multiply those using my good old iPhone. So I got 3 times 13 is, already know, need that, times 7 is 273, times 4, 1092, times 2, 200, 2,100. That was 3 times 13 times 7 times 4 times 2 is 2,184. What a fun store. And look at that. It's correct. All right, so have a great time and get all 100s, and I'll see you in class. But if you can't get all 100s, make sure to post some traffic light problems.